In last session we were discussing about this the first order differential equations. Now let's see how we're supposed to do the questions in exercise 5b. So if you start with the first question today, if you start with the question number 1, the part A, that is x dy by dx plus y is equals to cos x. This is the equation we are supposed to do. So if you have some kind of expression, this is in this differential equation both variables are involved. So like in this case, what you need to do is, if you want to do it, see whether the differentiation of the expression which is apart from variable of y is available here. Yeah, it's there. So you just write x. Then apart from the term or verified over here, the other expression. See whether the differentiation is available here. Yes, the differentiation of y is there. Therefore, you can say this is the differentiation of xy, which is equals to cos x. That's the next step of doing this question. Right. Then what you need to do is, then integrate the both sides. dxy by dx is equals to integration of cos x. So differentiation integration get cancelled, that turn out to xy is equals to integration of cos x is sin x plus c. So with that you can say y equals to sin x plus c over x. This is the answer, the final answer for question number 1, part A. But initially, that is a fact where we have to understand when we are working out with this kind of a question. Right. Then I will move up to part B. Yes. In part B, the question is e to the power minus x dy by dx minus e to the power xy minus e to the power xy is equals to x times of e to the power x. I think we did this question, but anyway, because they were like Madhushani and we had not today newly joined for this session, I'm going to do this question again. So what you need to do is initially see whether the term apart from the y variable, the differentiation is available here. Yes, it's there. There with that, this part. If you differentiate e to the power minus x, answer is minus e to the power, this should be minus x. So you can just write e to the power minus x. Then if you isolate this part, the other fraction of it, if you remove this one, the remaining term is y. Yes, the differentiation is available here. So with that you can say this is y. Then you can write this expression as d by dx of this is equals to x times of e to the power x. Then what you can do here is, then you can integrate the both sides. d e to the power minus xy over dx is equals to integration of x e to the power x. Then here the differentiation integration get cancelled and turn up to e to the power minus xy. This part of a differentiation integration, what you need to do is we have to simplify this. Simplify means we have to use the integration quotient called integration parts. Later on, when you are learning about the advanced integration, we learn this theory. For the moment, you have to memorize like this. If you have a integration somewhere like this, you can use integration by parts. I'll do that part over here like this. Initially, we'll consider this one as u and this one as v. Then if this is u is x, so now we have to find what is du by dx. Du by dx is 1. Then consider the other parts, or not v, this is considered as dv by dx. That's a way of doing it. Later on we learn how to do this. if dv by dx is equal to e to the power x, v is the integration of this, that is e to the power x. Then the formula over here is integration of u dv by dx. This formula is uv minus integration of v du by dx. We learned this, nothing to worry. So this is x e to the power x minus integration of v means e to the power x du by dx is 1. Then it's e to the power minus x minus e to the power x plus c. Right. So you can say this is x e to the power x minus e to the power x plus c. So you can say y is equals to x e to the power x minus e to the power x plus c over e to the power minus x. If you want, you can take this e to the power minus x minus x up as a plus power. So turn up to x e to the power 2x minus e to the power 2x plus c e to the power x. Can you can write the answer with that? That's the next format of doing this question. So nothing to worry about this integration. Just after another 1 or 2 weeks, will be
so that's
doing entire this integration part.
So that's product rule, right?
Product rule. Yeah, the product format of integration. That is called integration by parts. Within like by come the next Friday, not this Friday, next Friday, no, but you will be finishing this integration part as well. Nothing to worry. So after that, you will be so much familiar with that how to do this, right? Then let's move to the next part of the question. Yes. Then the next fact is I'll just do only one question today. I'll just come up with question number C. That is sin x dy by dx plus y cos x is equals to 3. Now see whether the differentiation of this is available here. It's there. Therefore, just write. You can say this is sin x. Then the other part of it is here. So you can just write y. Then you can write d by dx of this is equals to 3. Then I will integrate the both sides. So that is y sin x equals to 3x plus c. Therefore, y become 3x plus c divided by sin x. That's the final answer for that. Right. So like that you can do the question is exercise 5b today. Right. Then the next part comes. So if this integration is there, this is the simplest form of doing this. Then the next one is today, if you come up with the question number 2, find the general solutions of the differential equation. Question number 2 I'm referring to. dy by dx plus 2xy is equals to e to the power minus x squared. Minus x squared. Now there's a small issue. You can understand that today, apart from dy by dx, the term available here is 1. The differentiation is not available here. Right. Then we are on doubts. In this situation today, we do this equation in a form of like this. dy by dx plus fxy is equal to something, some kind of a function over here. There is a fact we consider integration by, integrating factor. We define a term called integrating factor. Integrating factor is for the e to the power integration of the function apart from y available here. Right. Then initially what we need to do is make it we need to find the integrating factor. Integrating factor is put there, e to the power integration of, if you isolate y, the rest of the term is 2x. Then you can get this integration factor is e to the power 2x integration is x squared. Then multiply this entire expression by this integrating factor. The entire expression should multiply with integrating factor. So what do you get with it? E to the power x squared dy by dx plus 2x e to the power x squared y is equals to e to the power x squared multiplied by e to the power, I just do it later on, we can simplify, minus x squared. Then now you can get this expression. Obviously when making integration, so you can get this answer, e to the power x squared. That is the objective of making this integrating factor. Y d by dx of that is equals to, make a simplify, turn up to 1 window. Okay, then you can say, then I can integrate the both sides. Then what do you get? This is turned up to e to the power x squared y is equals to x, therefore x plus c. Therefore y become x plus c over e to the power x squared is the answer for that. That's how we're doing this kind of a question.
So, for the integrating factor thing, do we need the proof how we get that?
Yeah, we can get it, no need of proving it. So only thing is that we have to assume it, but whether we have to find what is the integrating factor is that the question you ask. Or you ask to write this.
No, so now, yeah. No, that's step okay. I mean, they won't ask anything for the proof of how we get that integrating factor, right?
We have to write this step. Steps we need to do is you have to write this one, this one, this one, this one, and this one. These are the steps you should write with it. So you have to identify what is the integrating factor in the question. Okay? Yeah,
okay,
let's go to the next question. Yes. Right. The next question is Pute. Find the general solutions of the differential equation. Yes, I can have no need of working out because like question number 3. The question is x squared dy by dx is equals to 2, plus 2xy is equals to 2x plus 1 with it. Right. But they want is, so simply you can understand that the differentiation of this is available here. So straightforward, I can write x squared. Then the differentiation of this is over here, xy. You can write d by dx of this is equals to 2x plus 1. Then you can integrate the both sides. Then what you get here, x squared y is equals to x squared plus x plus c. Therefore, y become x squared plus x plus c over x squared. Right. Then we need to find the value for c. To find the value for c, they have given 3 different conditions. Therefore, you get 3 different equations. Then at minus half 0, you can say 0 is equals to half minus, minus, this is minus half, minus half, so it is done up to minus half squared plus minus half plus c divided by minus half squared. So if you work out over here, minus half squared is minus 104, c equals to 104. With that you can write the equation y equals to x squared over x squared is 1 plus x over x squared is 1 over x. C is 1 over 4 over x squared plus 1 over 4x squared. That is the final answer for this. That's the way of doing this question. Yeah, right. That is a way of doing this kind of question. So They might give you the boundary conditions. With that, you should be able to identify the answer for this. Let's go to the next question. Yeah, at the end, find the general solutions of the differential equation. If you move to question number 4, we need to find the general solutions of ln x dy by dx plus y over x is equals to 1 over x plus 1 x plus 2. Maybe this part of integration we need to learn a little bit of it. Apart from that, other sections are not that hard, but we will go with them. See. Now you can see the differentiation of ln x. It's here. 1 over x, so you can write ln x over here. The other part is here. It's y. So you can write this is d by dx of y ln x is equals to 1 over x plus 1 x plus 2. Then you can do the integration for the both sides. When you get system of y ln x is equals to integration of 1 over x plus 1 x plus 2. Later on we will learn how to do this integration. It joined to a joint theories that is called integration by partial fractions, right? Have we learned partial fractions?
So we did during sports midtime, I think.
Right. This is what. If you happen to see a differentiation like this, now see whether the differentiation of this denominator is available here. No, with the difference. Sorry, yes, if you expand this, that is equals to 3x plus 1. Initially, see whether the differentiation of this is available in the numerator. No, it's not available. In that situation, what you need to do is we have to do partial fraction for this. Right. Then I will do the partial fraction for this. X plus 1, x plus 2 is equals to a over x plus 1 plus b over x plus 2. A over x plus 1 plus b over x plus 2. Then you can write, if you take the LCM for the left hand side, sorry, right hand side. So it's turned out to LCM is x plus 1 into x plus 2, a times of x plus 1 plus, sorry, a times of x plus 2 plus b times of x plus 1. How to get it? Multiplication over here, cross multiply and write it over here. Then you can say, if you equate the numerators, 1 equals to a times of x plus 2 plus b times of x plus 1. So if you simplify, I will find the value for a and b. If I make x equals to minus 1, 1 is equals to a, this term get cancelled. If I make x equals to minus 2, 1 equals to minus 2, it's minus b. Therefore, b is equals to minus 1. Then you can write this partial fraction as 1 over x plus 1 minus 1 over x plus 2. Then you can write this one, integration of 1 over x plus 1 plus, sorry, minus 1 over x plus 2. Then we know that integration of 1 over ax plus b. We already learned this fact. It's 1 over a ln ax plus b for this. Yes, I'll write it a little bit clear. I think that part is not much clear with your screen. Integration of 1 over ax plus b. Answer is today 1 over a ln ax plus b. That's the answer for that. With that, you can say like this one. So, 1 over 1. Now, number in front of x is 1, so just write 1. So, you can say ln x plus 1 minus this part, you can again write ln x plus 2. So, now it of writing 1 over 1 is that plus c. So, just plus c. Yeah. Then, what you can get here is that you can say y ln x is equals to ln. Within this subtraction, you can write it as a 1 division. X plus 1 over x plus 2 plus c. So once again, you can find the particular solution which passes to the point 2, 2. Passing the point 2, 2. So what you do, you can just substitute 2 here. Ln 2, method ln 2 plus 1 is 3. 3 over 4 plus c. So the method c is equals to 2 ln 2 divide by ln 3 over 4, and you can with this with c, you can write a final. That's a way of doing this kind of a question.
Sir?
Yeah. Right.
Sir? Shouldn't it be minus ln 3 over 4?
Yeah. Sorry, I just made a mistake. Now it's much easy. So method 2 ln 2 minus ln 3 over 4 equals to 6. Yes, then આપણે મેકલેસી કરන්න පුළුවන්. ඒතර මේක ලියන්න පුළුවන් මෙහෙම පුතේ. ln 2 to the power 2 is 4 divided by 3 over 4 is equals to 6. So with that you can say 3 is equals to ln 16 over 3. So with that you can write the answer y ln x is equals to ln x plus 1 over x plus 2 plus ln 16 over 3. ඔන්න මේක තමයි අපිට සිම්ප්ලිෆයි කරන්න පුළුවන් ඊට පස්සේ just එතකොට මේකේ multiplication එක විදිහට you can write it today. Y ln x is equals to ln මේ multiplication ලියන්න පුළුවන් අපිට 16 x plus 1 over 3 x plus 2. Then you can write y equals to ln 16 x plus 1 over 3 x plus 2 divided by ln x cubed. That's the final answer for that today. Yeah, that's how to do it. Right. Then let's move to the next part of the questions. Right. Because it is all these things we can do it if you have this differentiation, just easier format of that. Then if you get what happen to find this much, but if I come up with that question number 5, this is a critical situation. dy by dx plus 2y is equals to e to the power x. Right. In this situation, what we can understand is the number here is 1, its differentiation is not available here. So therefore you cannot use that d by dx of this whole function technique, you cannot use. Then we need to find the integrating factor. How to identify the integrating factor? Isolate y from this expression and see whether what are the rest of the term is 2. So therefore you can say e to the power integration of 2. So this is done up to e to the power 2x. Right. Then multiply entire expression by e to the power 2x. Then this is done up to e to the power 2x dy by dx plus 2 e to the power 2x y e to the power x multiplied with e to the power 2x. Then what you can understand. Now simply, here the differentiation is available here, e to the power 2x, y differentiation is here y. That is the total differentiation of this, is the integration of that. So this is turned up to integration of, if when you multiply, the powers get added, e to the power turn up to 3x. Then this is turned up to e to the power 2x, y is equals to 1 over 3 e to the power 3x. The formula for e to the power ax plus b integration is 1 over a. Is the answer for that. So with that, you can get this answer. Then you can write plus c. Then you can say y is equals to 1 over 3 e to the power 3x divided by e to the power 2x. That is turned up to e to the power x. plus c e to the power minus 2x is the final answer. C value you can find it if they have given the boundary conditions. Right. In question number 5, part B, that is dy by dx plus y cot x is equals to 1. Right. Then what you can get here is, initially you can say that the integration of this is not available here. So you can find the integrating factor. Integrating factor is how much? Integrating factor is the e to the power integration, if you remove y from here, cot x. Right. So the integration of cot x is how much today? Ln cot x plus cosec x. So e and ln get cancels and turn up to cot x plus cosec x. Yeah. Then what you can get here is, then after that, multiply everything with this. Cot x plus cosec x. Yeah, then if you multiply everything, this is cot x plus cosec x dy by dx plus y to multiply to cot squared x plus cot x cosec x is equals to cot x plus cosec x. So the method after that is the differentiation of cot x plus cosec x into y is equals to cot x plus cosec x. Then you can do the integration from both sides. Then what you get here is, this is the cot x plus cosec x y is equals to ln integration of cot x is ln cot x plus cosec x plus ln cos x. Sorry, ln sin x. No, not ln sin x. This is turned up to integration of cosec x turn up into it has to be 1 over. Sorry, make this part is wrong. This is ln cot x is cos of sin ln. This is one second. Just and then the impression here. Cot x is sin over cos x. That is this is minus ln cos x. 1 over cos x comes. Yeah, that's it. Minus 1 is. So you can mark it without measuring anything. This is equals to e to the power. If you bring this e to other side, ln. If you bring it down, it's 1 over cos x. So 1 over cos x turn up to sec x. E and n don't get cancels and turn up to and then sec x with the right. So the measuring of it sec x dy by dx plus y sec x cot x is equals to sec x. So මෙතනින් අපිට ලියන්න පුළුවන් මේක dy by dx sec xy is equals to sec x කියලා, then integrate the both sides, then this is turn up to sec xy එකට එනවලු පුතේ x. What is the integration of sec x? Can you remember? That is ln sec x plus tan x. Make up integration plus you will be kind of familiar with that. Plus c, that you can say y equals to ln sec x plus tan x plus c over sec x. Get the final answer for that. That's a way of getting this answer. Yeah, that's all. Then then you can do this exercise 85b, and there's few more questions remaining with you. චුට්ටක් පුතේ මේකේ මේ exercise එක I think we have a little bit hold till we do this integration part, seems to be